Hello, I'm going to go through some of the data assurance considerations that an organization should perform. So what does this refer to? This refers to the checks made to determine if data that's been collected is going to be useful. It's how we tell whether what we've collected is actually good or rubbish. And this should be done at the creation phase of data lifecycle management. And there's no point moving past this phase unless you are sure that it's going to be useful. So the word assurance is a word which is used sometimes in real life, but not that often. Assurance means the confidence that something is true. So if I think Arsenal are going to win the Premier League, I've got high assurance that Arsenal are going to win the Premier League. And in terms of data, there are essentially different methods we can use, different checks we can make, which will either increase our confidence or decrease our confidence. And there are 8 on the course, which is a lot for you to learn. These are all different words, all mean different things, but collectively, the more of these you have in place, the more confident you are the data is going to be useful. So quite a lot to cover, unfortunately. We need to, first of all, define what each of these mean and say why each consideration is important. So accuracy refers to how free from errors the data is. Now, it's pretty clear that inaccurate data is a bad thing, but why is it bad? Well, if we have errors, it may lead to there being wrong analysis done later. We might also need to spend more time cleaning the data. If we are aware it's got lots of errors in, before going on to analysis, we need to do some cleaning. More time is taken doing that if we have inaccurate data. We need to make sure that our sources we're choosing initially are accurate to avoid issues further down in the pipeline. Quality is a little bit vague as a consideration. It kind of encompasses quite a few other ones. I would say quality refers to how complete, how consistent, and how relevant the data is. This is kind of an overall measure of how good the data is. If it's not complete, if it has some missing values, this could lead to analysis which doesn't reflect the actual reality because you're not actually taking into account all of the data you should be taking into account. If the data was irrelevant or wasn't quite specific enough to our particular scenario, that might lead to conclusions which aren't actually true. If I'm analysing data for aeroplanes, when I need to be analysing it for trains, it might lead to different conclusions which aren't actually relevant in my context. Redundancy refers to how many times data is repeated unnecessarily. So if I've got the same value held 5 times when it only needs to be held once, that is redundant. And this can often happen if I'm combining multiple sources together. That may lead to double counting, where the same value is being recorded in both separate sources. I'm then combining it and getting twice as many as I need to. That's often how we get redundancy in our data sets. This is bad because ultimately we're wasting storage space. I'm having to store the same value multiple times for no good reason. And if I don't cut out this redundancy before moving on to analysis, some conclusions, some trends might seem stronger than they actually are because of this repetition. Another consideration to talk about is reliability. This refers to how accurate and consistent it is over a period of time. So it's not about whether it's accurate once, it's about over a period of weeks and months and years, does it remain accurate? This is really important, especially if we have automated systems which are working over a period of time. An automated system gets set up by the engineer and left to run over a period of time. And if it's getting a data source which is unreliable, the actual system will not be able to work properly. For example, a speed camera isn't being monitored by a human all the time. A human sets up a speed camera, checks it's all working, but if the camera itself gets weaker over time and it starts misreading the speed of vehicles, then the actual speed camera itself will become unreliable because of the data source being unreliable. And if I'm looking at data over a period of time and it's not reliable, then it makes it really hard to make comparisons because they may not be reflective of what is actually happening if the underlying data is not being held reliably. Timeliness does refer to how up-to-date the data is, was it recently collected, and also how quickly it can be accessed. You might have data being accessed live and being really, really recent, but it may take a while to actually get to you, which would also impact the timeliness. This is important because outdated data may produce findings that are no longer true. And if it's slow to get to us, we might miss some trends if it's taking a long time to actually be received. For example, if I'm trying to make investments in the crypto market, if I'm getting my data a few days behind, I'm going to make wrong investments because I'm too late to discovering all of the trends. Validity refers to how much of the data is within the expected ranges and also in the expected format. So valid data is in the expected range and the expected format. Invalid data is out of these ranges and formats. And if we are consistently having data outside of our expected ranges or formats, this can be harder to store. It can also be harder to analyze because it might be beyond what we are set up to handle. And if we do have invalid data because it's well below our actual range, this may well distort calculations and lead to wrong conclusions being made. Now, the final two to look at are two V words again, validation and verification. These are a little bit different because they're more checks we can do rather than properties of data. So validation is trying to see whether data is valid or not. So this goes hand in hand with validity. Validation is checking that the data meets the required rules, format, or range, crucially before it is accepted. So before I store my data, I need to do some validation to make sure it's in the correct format. So for example, if I'm asking the user to enter an age should be a whole number. It shouldn't be a fractional number, and it should be probably between 0 and 130. An invalid age would be -5 or hello or 200. And we do validation to make sure we're not actually saving any invalid ages before we move on. So we are there to ensure the data stored is valid. If someone typed in -20 as their age and I just stored it, that's going to lead to some invalid analysis later because that's not a valid age. Verification is a little bit different. Verification is just checking the data being stored matches the original source. We often have errors being introduced when data is being copied from one place to another, and verification is just checking that a mistake wasn't made when doing that. So for example, if there is some really important information, you might get two separate people to enter it and then compare what they entered. If it's the same, it suggests that it was copied correctly. If one of them made a mistake, it should get picked up by the other person. That's the idea of that. And also, we do this a lot when we're asked to sign up for an account. We'll often be asked to put in our email address twice or our password put in twice to prevent errors being introduced by copying things. And the goal here is to ensure the data remains as accurate as it was originally. If the data was inaccurate originally, this won't make things any better, but it means that if we had accurate data, it shouldn't become inaccurate because we didn't copy it properly. So you've got to do your best to try and learn those 8 keywords, I'm afraid. But the key goal here is to look at a scenario and use those 8 considerations to decide whether the data is useful based on those properties or not. So here are 3 possible scenarios. Let's think about what considerations perhaps apply. So if I have a server recording the latest stock market values and it was turned off for 2 whole days, that is going to impact the quality of it because it's going to be less complete because I'm missing 2 whole days of data. This also might mean it's less reliable than I thought because there's a risk that if it was turned off for 2 days, this could happen again in the future. I perhaps can't trust it to the same extent that I could previously. If a temperature sensor is producing occasional negative values, even during summertime, that suggests there are some errors being produced, which means the accuracy can no longer be as high. In terms of what checks I could put in place to prevent this being an issue, well, I might do some validation before I save any of these values to try and remove any data outside of the expected range. Perhaps I do a check to see, is the temperature above 0, which is likely to be in the summer. Anything below 0 must be an error, therefore I won't actually save it. And let's say a bus tracker is taking up to 5 minutes to process and send the data to a mobile app. How useful is that based on our different properties? Well, the most relevant there perhaps is the timeliness. It's taking up to 5 minutes to get this data. Thinking about that scenario, if you're waiting for a bus might come in less than 5 minutes. Therefore, that might be too long for the data to actually be useful to the users. We might need it to be accessed a lot faster. And this might also affect the quality if I'm not trusting that this is always going to be done consistently, and also the reliability, especially if it's not always 5 minutes. If it's up to, that can mean that it's sometimes a lot shorter. That again impacts how reliable the data is and perhaps how useful it is to users.